Alright, y'all, I'm starting back on page 8. So I think this is going to be a pretty quick video because this is pretty similar to the very first video I ever did. But we have 5 different functions this time. Also, I convinced myself this was okay to wear because I don't think anyone cares anymore. So it wants you to, again, discuss the parent function and then sketch the graph. So again, just so we're all on the same page, I'm going to sketch these up here for you, although you could easily Google them or graph them yourself. Okay, so we have both square root and cube root. So we have y equals square root of x and y equals the third root of x. Okay, so there's like an imaginary 2 here. We just never put it there. But when we have other numbers other than 2, that's when we put it there. So this is square root and this is the cube root. So, although you might think they look similar, they're actually pretty different looking graphs. So for this one, it starts here and it kind of does this arch kind of thing. While this one is hard to accurately draw. So I'm going to show you a picture that I have here, but it's kind of like it's a weird snaky one again, and I can't draw the snaky one. So I'm going to show you. So this has the square root and the cube root functions side by side. So you can see how this one is just this slight arch, and this one is a snaky business here. So although they're both roots, they do look different. Okay, and then we have an exponential, which will be your y equals e to the x. So this one has so it never crosses the x-axis, so it kind of trickles down forever really, really, really close, and then shoots up. So when you hear people talking about things are increasing exponentially, that's where this comes from, because this graph shoots up so quickly. If you look at a graph that goes further than this, you'll see how quickly it rises. It's much different than this, where it just goes curved. This one shoots up very quickly. Okay, so we have the log function. Okay, so y equals log of x. Okay, and that one, so this one's kind of opposite of the exponential, which makes sense in a calculus sense. I'm not sure if you guys have worked with that yet. You probably have. It's kind of the opposite. So this one, so instead of how the exponential never touched the x and then shot up that way, so this one comes down or up from this way, never touching the y, and then shoots out this way. And then rational, I would call this reciprocal, just so it makes more sense, because what this looks like is y equals 1 over x. So just in my head, calling that reciprocal makes more sense. And it's easier to find stuff on Google about it if you call it reciprocal. So this one has 2 different pieces to it. So it has this piece in quadrant 1, and it has this other piece in quadrant 2. Super weird graph, but that's what it is. And if you need to Google it to get a better image, I encourage. Okay, so pages 8 and 9 and 10 are all just the same as what we have been doing with the other functions. It's asking the same questions. So instead of going over what these questions mean, I'm just going to run through the answer to number 3, because sometimes I think it's more helpful to actually go through an example. And if you need assistance on what the questions are asking, I think it was video 1 that I went over what every single one was talking about. So all of the questions are obviously going to be one of the 5 functions above, I believe. That's what they're doing here. Oh, and then 1 and 2, those are the transformation ones. And again, I discussed different transformations in video 1, but that's also a very easily Googleable thing. So you can see in number 1, that's obviously the rational function. And then number 2, that's the cubed root function. And then you just discuss what transformations are occurring. Okay, so number 1, we have a square root function. Okay, so we have y equals, or f of x equals 3 square root of x plus 1. Okay, so like always, the first step is to graph these. And I just want to like directly show you guys what I did to graph this function. My calculator, even like the TIs, are so small, like the screen, and it's really frustrating for me to try to see. So I prefer, I mean, I know that not everyone has these resources, but I prefer to use, even if you use your phone, I use my laptop to graph these to get a better picture. But totally doable on your calculator. I am just a diva. Okay, so I use Desmos. You could also use Wolfram Alpha. There's something called Symbolab. There's a lot of different options here. So you pull up your Desmos, and I just typed in my function. So y equals 3 times. So if you pull up your little keyboard here, you can find square root, I believe. Functions. So it has like the root with the n. So you can change whatever. I'm just doing a square root, a normal. But that would help you if you're doing the cube root. Square root of x plus 1. Okay. So you have your little graph here. But unless you're just doing a sketch, this isn't very helpful. Like, I wanted my table of values so that I could get a few points. So you then, if you're using Desmos, so this wheel, click on that, and then you can click on this table. And you have all of these points. And you can even, like, put your own point in forever. And it gives you your table there. And then I just plotted those points. Okay? So I just plotted enough where I could sketch out my little graph. Okay? So I'll do that here. So you can see here, for a lot of these graphs, pretty much all of them, you have some kind of asymptote. And I think that should be a familiar term. A line, vertical or horizontal, that it gets really, really, really close to but never touches. And you can see here on my table, I have, like, it says the coordinate point -2 and the y value is undefined. So that means I have some kind of asymptote somewhere. So I just went first to the points ahead as defined. So I have 0, 1. Then I have 1, 4. Then I have 2, 5 point some, 3, 6 point some. So it's like, it's curving off. We know the general shape of the square root function, so I could kind of guess. So it'll kind of go like that. Okay? So it never goes into this territory. That's why I said for -1, it was an undefined y coordinate. So looking at the domain, we know that those are our x's. So my domain here So I'm going to look at my x's and see where they start and see how long they're defined for. So I don't have any negatives in my domain that are accounted for. They don't start until right at 0. And then they're accounted for forever, right? If you took your pen and went forever, you would have an x value for every single point you were at. So my domain is, 0, infinity. That's an infinity sign. Okay, my range. So now I'm looking at my y's, okay? So starting at the very bottom, I don't have any negative y's. In fact, I don't even have any y's at 0. I don't have a y until I reach that 1. That coordinate point 0, 1. I don't have my y starting until 1. Okay, so my range will be 1. But they do continue all the way to infinity. They will be accounted for. Okay? x-intercepts, clearly we don't have any x-intercepts. Y-intercept, you can see it hits the y at 1. My increasing intervals, okay? So, I know it looks something like, I have to fill in these blanks. My x's are increasing between what and what. So, my domain kind of helps me with this. So, my x's, since this is increasing the whole time, I really just have to know when it starts increasing, which is when the function begins on the x's, which is really like my domain. So, my x's begin increasing at 0, because we know that's when my x's start, and that's where my function starts. So my function starts increasing in the very, very beginning at 0, and it's increasing forever. So that's my interval of increasing. I don't have any point of this graph that's decreasing, so I put none. And then end behavior, remember that's the as x approaches infinity, what are the y's doing? And then the second line here is supposed to be as x approaches negative infinity, what are the y's doing? But we don't have any x's in the negative area here, so I just left that one blank. All these functions are different, and so you'll run across things where it's like, oh, well, that one doesn't apply to my function. So as x is approaching infinity, or negative infinity, well, that's not even happening on this graph. We don't have any negative x's at all in this function. So we're really only dealing with this. That makes sense because we're talking about end behavior. What are the ends doing? Well, this function only has one, end. It's never going the opposite direction. And that's why we didn't have an interval of decreasing, and we don't have the other side of the end behavior. Okay, so as x approaches infinity, my y's are also approaching positive infinity. Okay. And in video 1, I think it was video 1. May have been video 2, I don't remember now. But there is a way to determine end behavior just based on what the function looks like. It's a little bit confusing though. Thinking back to that video, I think it's sometimes easier to just visualize what's going on. But sometimes you have to do it based on only the equation. For these purposes, you'll have the graph, so that's nice. So that's all you're doing for pages 8, 9, and 10. You'll just graph them, get a table somehow to graph, and then answer those questions. Oh, okay, so for some of these, at least for page 9, the next page, you have spots for asymptotes. I think this should be familiar with you guys though. And even for these, they have a place for vertical and horizontal asymptote. So obviously a vertical asymptote is going to be a vertical line. Let's look at the y equals log x. So that has a vertical asymptote. It's actually the y-axis. So it's getting really, really, really close to that line, but it's never touching it. Now if you look at y equals e to the x, that one has a horizontal asymptote because that's getting, and it's actually the x-axis. It's getting really, really, really close to that line, but it's never touching it. Okay, so for, let's see. Yeah, so for the reciprocal graph, that funky one, so that's going to have a vertical asymptote and a horizontal one, and that's why you have blanks for both of those for number 11 and number 12 on page 10. So just remember how we write the equation of a vertical and horizontal line. So if it was a vertical asymptote, and it looks like this, it's going to be, so vertical asymptote. There's a P in there, asymptote. And then horizontal. So vertical asymptote will be of the form x equals something. And then the horizontal, this way, asymptote, will be of the form y equals something. Okay? As long as we're on the same page with the way you write things. So that takes us through page 10, and then page 11. So it says at the top, mixed questions on all functions. So I think they're throwing in all 10 of the functions that we have discussed so far. But they're just asking the same questions that pretty much these kinds of questions are asking. So like range and increasing and decreasing functions. So I think you guys should be fine. This is just a review of like all the functions asking questions like these. So that'll take us through, I think, all the functions that we discuss in this packet. So I'll see you all in the next video.